cylinder, except it's multiplied by a factor of a third because you're shaving off these pieces here. And there's a mathematical way to show how to get that, but we're not going to go into that detail right now. So this is the volume for a cone that you will need to remember. So first it wants us to just find the volume of the cone in terms of pi. So we're just going to sub in all the values that we were given. So radius is 7. We are squaring that. And then we have height, which is 5, multiplying that in. Now 7 squared is 49, and 49 times 5 is almost 50 times 5, which would be 250. And then I need to subtract, so 245. Let's double check it. So 49 times 5, 245, sweet. And then we divide that by 3. So I'm just going to leave it as a fraction. 245 over 3 pi is what we should get right there. And then our units were in inches, so this should be in inches cubed. Okay, so this is my final answer for part A. Okay. And then lastly, it says find the volume to the nearest cubic inch. So I need to actually multiply this out. So 245 over 3 pi. So I'm going to put that in my calculator. 245 over 3, and then times pi should give me 256.5634. Interesting that it doesn't go on forever. So now that's like got to be a mistake by the calculator because pi is irrational and the product of anyways. Okay, so this is going to give me 256.5634. Now it wants it to the nearest cubic inch, which is this place right here, okay? That's the single inch that we're looking at. So I'm going to draw my little dashed line. That was my decimal. I'm going to use the place before it to round up. So 6 rounds up to 7. So I should have 257 inches cubed. Okay, and that would be my final answer for part B. All right, let's take a look at the back. All right, so it looks like there is one more piece that we haven't covered yet, and the rest are already covered by the ones that we've done on the front. So we're going to flip over and we're going to jump to number 6, okay? This is a cube. We have not done a cube yet. All of these other ones you have done. So I want you to use these as practice and then check yourself with the solutions when you're done. And let me know how it goes. I will post solutions to every single one of these problems. I'm just not going to explain every single one of these. Okay, so because the other 5 problems on this back are very similar to the front. They use the same formulas. Okay, so now we have number 6. The measure of each edge of a cube is represented by 2y minus 3 centimeters. Okay, so I'm going to draw out a cube. Excuse me. Okay. And we would have maybe something like this. Okay, there's our cube-ish. And each edge is 2y minus 3 centimeters. And it tells us that the volume of the cube, or it says find the volume of the cube, and it gives us a specific value of y to use. Okay, so remember that volume of a cube is specifically each side cubed. So it would be if x is the side of the cube, then it would be cubed. But for a general rectangular prism, remember that it's length times width times height. And for a cube, length, width, and height happen to all be the same thing, okay? So there are 2 ways to do this. You might look at this and say, hey, this is just 2y minus 3 quantity cubed. You could cube that expression and then plug in y. That is going to take a long time. So what I suggest you do is take 2y minus 3, sub in your y, 7.25. Okay, and 7.25 times 2 is going to be 14.5, minus 3 should give me 11.5. Now I can take this value and I can sub it into my volume formula. Okay, so this is volume for a cube here, where x is the length of one of the sides, and this is for a rectangular prism. Okay, so these are the important formulas that you need for these notes. Okay, and now when I sub in my 11.5, my volume should be 11.5 times 11.5 times 11.5, or 11.5 cubed. Okay, either way is fine. And when I sub that into my calculator, I get 1,520.875. Okay, and then this was in centimeters, so I need centimeters cubed as my volume. Don't forget your units, those are super important. Okay, so I'm going to post solutions to all of this. I'm going to post, actually, I think another teacher made a solutions video for the whole back. So you will have somebody explaining all the back problems, and she might explain this problem better, and you might like that better. So I'll post that on this, and then you can do the rest of these for practice, or you can follow along with Miss Casey. And then I have another practice assignment for you to do, and your homework. So that should be all. Good luck, guys. I hope you're doing well. I miss you all so much. I wish we could go back to school. All right, I'll talk to you later.